To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all electrochemistry. This is the 12th lesson of your grade 11 science textbook and it is a chemistry lesson. So in previous lessons, you all have studied about electricity. You all know what electricity is. It is the flow of charges. So that gives rise to an electric current. You are familiar with that. Then you are familiar with chemical reactions also. Now different types of chemical reactions, how they occur, how reactants are converted to products, all that is familiar to you. Now in this lesson, since it is electrochemistry, we will try to understand the relationship between a chemical reaction and electricity, or electricity and how a chemical reaction can be induced by electricity. So that is the lesson here. With that introduction, students, I will move on to the next slide where we look at the contents of this particular lesson. Electrochemistry. Now in this, we will be first discussing electrochemical cells. Now you are familiar with cells, dry cells that we use for different circuits. In your household also you have dry cells, the normal batteries. Now these are a type of electrochemical cells. So here we will try to understand how an electrochemical cell functions and how electricity is generated by a chemical reaction. Then the second topic is electrolysis or electrolysis. Now by passing electric current, if you can separate a complex component into more simpler components, then that particular process will be understood as electrolysis. Now this has to be a process that doesn't occur spontaneously. Normally at room temperature you can't make it happen. But by passing electricity you can make that happen. So those are types of reactions that are discussed under electrolysis. Then we have corrosion of metals. You are familiar with that also. Now in the lab we have magnesium strips. Now when you keep it exposed to air, you all know there is the magnesium oxide layer forming on it. Same way rusting of iron. Now all those come under corrosion of metals. So we will be discussing that as well. Electrochemical cells, electrolysis and corrosion of metals. So those are the topics that are going to be discussed under this lesson. So with that introduction, students, I will move on to the lesson. So first, we will discuss what electrochemical cells are. Look at these pictures first. Now most of these are familiar to you all. You all have either used it or have it at home. At least you all know about all these devices. A toy car powered by batteries. The remote control cars. Now here you can see this is the toy car, the remote control, and this is the power pack that you get with the toy car, either both to charge the car as well as the power pack. So there, of course, you would have seen now this is connected to the car, and when you plug it in, the car gets charged. At the same time, for the remote control, you will need to use batteries. And in that, you would have seen these two types of batteries. Normally, we put the dry cells into the remote control, whereas a type of cell like this is used in the toy car. That is a rechargeable battery. So these two types of batteries, a normal battery and a rechargeable battery, both are type of electrochemical cells. The dry cells, the batteries are electrochemical cells. Then an electric torch. Now you all are familiar with different sizes of batteries. A size, AA size, AAA size, like that you have seen different sizes. Then we have 1.5 volt batteries, 9 volt batteries. Like that you have seen different sizes, shapes and the different voltages that are produced by those batteries. So here electric torch uses batteries. Then mobile phones. We do have mobile phones, again different sizes and shapes. There are some batteries that can be taken out from the mobile phone, but the most modern ones you cannot remove the casing and take out the battery. But there is a dry cell in it. Then you have the calculators. Now here you can see this is a solar powered calculator. Here it's a solar cell. Automatically it generates electricity in the presence of light. At the same time there will be batteries inside. So a calculator uses batteries. Then a computer. Now we use the computer, the laptops, normally they run on batteries. Then you can recharge it. When the battery is low, you recharge it, connect it to the power source and you get it recharged. So there is a battery being used. In addition to this, there are so many other equipments, devices or materials that use batteries, even a wristwatch. So many things. So all those use dry cells or batteries. And these batteries are electrochemical cells. Because inside the battery, there is a chemical reaction taking place that generates electricity. So they are all electrochemical cells. Now if we look at the introduction, in our everyday life, we frequently use equipment powered by domestic electricity. One form is domestic electricity, as well as appliances operated by electrochemical cells or batteries. So like I told you all, we charge the laptop, we charge the toy cars, then we use the domestic electricity. You have learnt about electricity also. So then you are very familiar with that. Otherwise, we use electrochemical cells or batteries. Toy cars, electric torches, calculators, computers and mobile phones are a few examples for equipment that are powered by electrochemical cells. So those are a few equipment. You can think about many more equipments that you use at home. So that is just the introduction to this lesson, students. Again, I will move on to the next slide. The electrochemical cells or batteries used in the examples given above are small in size. Now first look at all these batteries. Like I told you all, now this is a 9-volt battery, flat and a rectangular shape. There are many like that. Then you have seen these cylindrical shaped batteries. That also you get in different sizes. Like I told you all, the A, AA, AAA, like that you have different sizes. Here you can see those. Then here also somewhat different shapes. Cylindrical, but like it's the surface is not very smooth. Then we have all these small batteries which are button-like batteries. Very tiny, round, small cells which you normally put into use for wristwatches and devices, appliances like that. So you get batteries of different shapes and different sizes. Here it is a pack of batteries also. Like that also you can get. Now these are usually small and usually they are just individual batteries with the positive and negative terminal. Just one battery. Now this is for small devices. But if you take a motor vehicle, a car, van, they also use batteries. Now here you can see this is a battery of a car, a vehicle battery. Now that is a large battery which consists of more than one batteries combined together. And they are all connected in a series manner. We have discussed this with electricity lesson also. So that the potential difference gets added up. So they provide a higher potential difference. So this is a large battery which is made up of more than one or several batteries or electrochemical cells. So you have to keep that in mind. You can use the batteries or electrochemical cells individually, or you can combine them together at that instance, or you can have a battery where they have been already combined together. I'm sure you all can understand that. So here you can see a battery used to start a car is large in size. Such a battery is a collection of several electrochemical cells. So here you have different sizes and shapes. Now this is one and that is another point, just for you all to recall what you already know. Because you are using batteries in your day-to-day life. So you are familiar with small batteries and large batteries. So that is again part of the introduction. We are yet to go into the lesson where we really discuss how battery produces electricity from chemical reactions. So for that, I'll move on to the next slide. So to understand the function of a battery or a dry cell or an electrochemical cell, first we need to understand what happens when you make two reactants to react, and from there what happens when chemical energy is converted to electric energy, or how that happens. Now for us to have a battery, we need to draw out current from the battery. So their electric energy has to be given out. But those are chemicals that give out the electric energy. So there has to be an energy conversion from chemical energy to electric energy. That is what happens in a dry cell or an electrochemical cell. So the chemical energy stored in the chemicals they contain is converted to electrical energy. So here energy conversion is from chemical energy to electrical energy. Now you all know, students, in a battery there are two terminals, the positive terminal and the negative terminal. Now these terminals are actually known as electrodes in electrochemical cells. So we will first try to understand what happens at those two terminals. So to do that, we will look at this activity. Now here, activity is to study the reactions occurring in electrochemical cells and the action of those cells. So to do that, we need these materials. Here you can see we need a beaker. Then we need sulfuric acid, and that also dilute sulfuric acid. So now you are familiar with acids and how they act in a solution, and also you are familiar with dilute and concentrated acid. So you all know sulfuric acid is a strong acid and it dissociates completely, as well as we need to take the dilute solution of sulfuric acid. Then we need a zinc plate or zinc strip, a piece of zinc metal or even a zinc rod. So mainly we need zinc. So we need a beaker, we need sulfuric acid and a piece of zinc. This is what we will do. We will take a small amount of sulfuric acid into the beaker, and then into that you will insert the zinc, and then you need to observe what happens. So that's a simple activity. I will discuss the method in the next slide first. So the method is this. This is what we are going to do. We have the beaker here. So we have the beaker. Inside the beaker, we take the dilute sulfuric acid. And to that, we insert the zinc metal. So this is the setup for the activity. You have the beaker, in that dilute sulfuric acid, and then you insert the zinc and you observe what happens there. Add dilute sulfuric acid. So here you have to remember it has to be dilute sulfuric acid to the small beaker. Place a strip of zinc metal sheet in the beaker. So it is a zinc strip, or like I said, a piece of zinc, but there it shouldn't be a crunched piece. It has to be somewhat long and where you can observe. Part of it has to be within the solution, the rest has to be outside. So like that, it has to be somewhat long. So that is why we use a strip of zinc metal sheet in the beaker so that a part of it dips in the sulfuric acid solution as shown in the figure. Not the full thing. Normally earlier when we used to observe reactions, we used to put the metal into acid. But here we need to have part of the metal outside, part of it inside. So that is why it has to be either a strip or a rod or a plate. You all know the difference, right? So then you need to record the observation. A very simple activity to understand what happens in an electrochemical cell. So let's go to the lab and do this activity now. Okay students, so now we'll try to understand what happens in an electrochemical cell. So as we discussed, you all know there is a chemical reaction taking place in a cell that leads to the production of electricity. So that is why we call them as electrochemical cells. So in electrochemical cells, there are two terminals, the positive and negative terminals, and they are referred to as electrodes. The positive and negative electrode when we look at the function of a cell. So to understand that, first we will do this simple activity where we have a metal that is zinc metal. Here you can see this is a zinc metal. And here I have sulfuric acid. So you're familiar with acids. Sulfuric acid is a concentrated acid. So in the solution, it dissociates to form H+ ions and sulfate ions. And zinc is a metal. So if we put this metal strip, that is zinc strip, into sulfuric acid, you all have to observe what happens under the solution. Can you all see the evolving of gas bubbles? The gas bubbles are liberated. Around the metal strip, you can see that. Even if I rotate, you will be able to see the gas bubbles. Here you can see. So this is how an electrode functions. Now, like I said, sulfuric acid dissociates to form H+ ions and sulfate ions. At the same time, now zinc is a metal that has the positive nucleus and the negative electrons. You all know in a metal, the electrons are free. So when zinc is put into sulfuric acid, what happens? Hydrogen gas is liberated. That is what you see here. Around the zinc metal, you can see the hydrogen gas. So that is because H+ ions from sulfuric acid take up electrons from the zinc metal and then they get converted to hydrogen gas. At the same time, can you all observe the zinc metal? You will not see a color change, but you can see the zinc metal becoming more clear. If you compare the top part of the metal and the bottom part of the metal, you will see a difference in their color. The bottom, which is under the solution, becomes more shinier. That is because the zinc plate or the zinc metal dissolves. So here zinc is dissolving and hydrogen gas is being evolved. So those are the changes taking place in this particular system. And this system where we put a metal into an acid is known as an electrode. So this is a zinc electrode. Okay students, so you saw what happens when we dip a zinc plate in diluted sulfuric acid. What happened there? You were able to see the zinc plate dissolve or react with sulfuric acid. There you saw the zinc plate dissolving and you were able to see gas bubbles evolving. Liberation of gas bubbles. Those were the observations that we got. So here you saw the zinc plate or sheet dissolves then gas bubbles evolve near the zinc sheet. So those were the observations. And also If you let it to react for a long time, if the amount of acid and the zinc is high, then of course if you feel the beaker, you will know there is a certain amount of heat generated. The beaker will become hot because you all know reaction of a metal with an acid is an exothermic reaction. You are familiar with those types of reactions also. A chemical reaction where there is heat evolved during the reaction because the heat or the heat energy contained in the reactants is more and the energy of the products is less. Because of that, heat is released during the reaction. So therefore, the beaker also will be warm. That also you can feel, but that was not our concern in this particular activity. These were the important observations for us. Now, why does this happen? To understand that, if we try to understand the reason for this, this is what happens. Now, if you take dilute sulfuric acid, now like I said, how do we write this? We can use the physical state. Normally, you are familiar with that also. We write the physical state within brackets. Now, this is dilute sulfuric acid. That means it is an aqueous solution. Sulfuric acid dissolved in water, aqueous solution. So, that is what I have indicated here. Now, you all know dilute sulfuric acid is a strong acid. What is a strong acid? A substance, acidic substance that completely dissociates in the solution. So, there what happens when you take H2SO4 aqueous in the solution, it completely dissociates and forms H plus ions and sulfate ions, SO4 2 minus aqueous. So, both are also in the solution state. H2SO4 dissociates completely and forms H plus ions and sulfate ions. If you balance it to H plus. So, this is complete dissociation. Complete dissociation. Now, at the same time, when you place zinc in sulfuric acid, what happens there? You all know H2SO4, this is a reaction that is familiar to you all. Zinc plus H2SO4, it gives rise to zinc sulfate plus H2 gas. This is the reaction that you are familiar with. Now, in this, here zinc is in the metal state. But here, zinc is in the zinc 2 plus state. That is what you need to understand. Now, this particular zinc is in the zinc 2 plus state. That is why it is ZnSO4, no? SO4 2 minus, so zinc is 2 plus. So, in this reaction, what has happened to zinc? Now, zinc was in the metal form. I'll use a different color just for you all to understand. Now, zinc is a metal solid. So, we indicate the state of zinc as solid. And this zinc becomes Zn2 plus ions. So, for a metal, an atom to become a positive ion or a cation, what should happen? Electron should be removed from this particular zinc. So, from zinc, electrons are lost and because of that, they become Zn2 plus ions or zinc 2 plus ions. And here, this will be in the aqueous state. Now, zinc is the solid. Zinc reacts due to acid and becomes zinc 2 plus ions by losing 2 electrons. And these zinc 2 plus ions cannot remain in the metal. They go into the solution. So, that is why this becomes aqueous. And because they go into the solution only, you see the zinc plate dissolving. So this is why we see the zinc plate dissolves or zinc sheet dissolves. Dissolves because the solid goes into the aqueous state as ions. And when a species, now these are new terms that you all have to understand. We'll be discussing these terms throughout the lesson. When a species, now zinc becomes zinc plus, losing 2 electrons. So zinc is a species that is losing 2 electrons. When a species loses electrons, we call that reaction as an oxidation reaction. You have to remember all these terms. Now this is known as an oxidation reaction. Oxidation reaction. Oxidation reaction means a species loses electrons. So zinc is the species, it is losing electrons. And normally you all know when you write a chemical reaction or a change, we always use plus. So although zinc is losing, we write the electrons in the product side, having a plus there. Zinc 2 plus aqueous plus 2 electrons. Is that clear? So as you put the zinc metal into dilute sulfuric acid, zinc will get oxidized. That means zinc solid will become zinc 2 plus aqueous ions, losing 2 electrons. That is the meaning of an oxidation reaction. Zinc is getting oxidized. So what happens there? Now if you take the system, this is the beaker containing the acid and the zinc metal. Now in this, zinc is losing electrons, and from here when zinc loses electrons, it will go into solution as zinc 2 plus. So where do those electrons go? They remain in this zinc sheet. So zinc loses electrons, the zinc solid loses electrons, and the zinc 2 plus ions go into the solution. At the same time, electrons remain on the zinc sheet. So electrons are negative charges. Here these are negative charges. Negative charges. Now we saw sulfuric acid has already dissociated. Now from sulfuric acid, we have H plus ions. Now H plus ions are positive charges. So what happens to these charges? The positively charged H plus gets attracted to the negatively charged electrons. So H plus goes towards the zinc sheet. And there what happens is H plus ions, now they are again in the aqueous state. They take up electrons to form H2 gas. Now here to balance this, since there are 2 hydrogens, you need 2 H plus ions. They need to take up 2 electrons. So 2 H plus aqueous takes up 2 electrons and forms H2 gas. Now can you all understand the changes? We put the zinc metal into dilute sulfuric acid. Already the dilute sulfuric acid, it's dissociated into H plus ions and sulfate ions. So as you put the zinc metal, zinc reacts getting oxidized and forming Zn2 plus ions. So there the electrons are left behind on the zinc metal. And these H plus ions get attracted to the negatively charged electrons. And they take up electrons and become H2 gas. So here H plus is taking up electrons. when a species takes up electrons, we call that as a reduction reaction. Now this is oxidation, this is reduction. Again, I'll use another color. A reduction reaction. That is a species taking up electrons. Is that okay, students? So two types of reactions occur. One species loses electrons, that is zinc, that is oxidation. At the same time, another species takes up electrons, that is reduction. Both of those take place. So charges are moving. Electrons are being lost and gained. Now this is happening in one metal dipped in a dilute sulfuric acid solution. If we can make this to happen through an external circuit. Now if we can have two such systems, and if we can make the electrons to flow through the external circuit or an external conductor, then we can make electricity to flow. That is how an electrochemical cell will function. So in this, one metal dipped in a acid solution. One metal dipped in an acid solution is usually known as an electrode. One electrode. But for electrons to flow through the external circuit or the external conductor, we need to have two electrodes. So when you have two electrodes, electricity can be generated. That is when we have an electrochemical cell. So this is the initial part where you understand what happens when you put a metal into acid. So after that, we will be discussing electrochemical cells. So although I have explained all these ones, I'll be again explaining it to you all with the reactions in order. So this is what happens. Before I go to the next slide, I'll quickly go back and again we will see what happens. Now during the activity, you were able to see the zinc plate dissolve and gas bubbles evolve near the zinc sheet. So the reason for that is this. You know, dilute sulfuric acid is a strong acid. So because of that, it undergoes complete dissociation, and these are the products. H2SO4 aqueous becomes 2H plus aqueous and SO4 2 minus aqueous. You're familiar with all the physical states. S for solid, L for liquid, G for gas, and AQ for aqueous solutions. So after that happens, when you put zinc into sulfuric acid, here also we can write the states. Now here also we can put zinc solid and H2SO4 aqueous. Here also this will be zinc sulfate aqueous and hydrogen gas. So always remember, students, the modern method of writing the physical state of a reactant and products is to write them along with the reactants and products within brackets. You don't write it as subscript. You have to write it along with the components. So zinc solid with H2SO4 aqueous gives rise to zinc sulfate aqueous plus H2 gas, if you include the physical states. So here, this is what happened. Zinc solid becomes zinc 2 plus aqueous by losing electrons, and that particular reaction is known as an oxidation. So here we can say zinc gets oxidized. So because of that, the zinc solid becomes zinc 2 plus aqueous. That is what we see as the zinc sheet dissolving of zinc. Then, when you put zinc into dilute sulfuric acid, zinc loses electrons and goes into the solution as zinc 2 plus ions, At the same time, the electrons remain on the zinc sheet itself. And the H plus ions that came from sulfuric acid get attracted to the electrons. So there they go near the zinc plate and there they take up electrons and become H2 gas. So when a species takes up electrons, it is known as reduction. So H plus aqueous, 2H plus aqueous takes up electrons and they become H2 gas. This is a reduction reaction. And in these students, now the two reactions that we wrote, you can see these two reactions. Zinc solid becoming zinc 2 plus losing electrons. That is an oxidation reaction. And 2H plus aqueous taking up electrons and forming H2 gas. One thing you have to notice, we don't put any physical states for electrons because electrons are subatomic particles. So you don't write physical states for electrons. You have to remember that. And also, these two are different from the reactions you have been writing so far. In all the reactions, you had the reactants, products. You never had electrons or charges in them. This is the first time we are using these types of reactions where you have charges H plus 2 electrons. Here zinc 2 plus 2 electrons. So when you write an equation where you have electrons and charges, we call those reactions or equations as half equations or half reactions. Because this is part of the reaction, this is part of the reaction. You all know the complete reaction, but zinc with sulfuric acid gives rise to zinc sulfate and H2. That is the complete reaction. So here we have half reactions and these equations are known as half ionic equations. So you have to remember that also. Now both these reactions, zinc solid giving rise to zinc 2 plus aqueous losing 2 electrons and 2H plus aqueous taking up 2 electrons to give H2 gas. Both these are half reactions. And therefore, these equations are known as half ionic equations. So here students, I'm doing it once here and starting from the next slide, I'll be repeating all these reactions because this is the first time y'all are using half reactions or half ionic equations and you're trying to understand the concept of oxidation and reduction. That is why I'll be repeating these again as well. So there are two half reactions. If you add them together, this is 1, this is 2. If you add 1 and 2, here when you add, always you have to look at the number of electrons. Now here 2 electrons, here 2 electrons. Then of course no problem. Otherwise you have to make sure that the number of electrons are equal. So here you can directly add them together. When you add them together, zinc solid plus 2H plus aqueous plus 2 electrons give rise to Zn2 plus aqueous plus H2 gas plus 2 electrons. You can compare. Now zinc solid plus 2H plus aqueous plus 2 electrons. And on this side, product side, you have zinc 2 plus aqueous, you have H2 gas, and again you have 2 electrons. So in this, we have electrons in the reactant side, electrons in the product side, and both are equal. So because of that, you can cancel off the electrons. And when you cancel them off, and if you write the remaining equation, you will get zinc solid plus 2H plus aqueous, giving rise to zinc 2 plus aqueous plus H2 gas. That is a reaction. And in this, already there is sulfate ion in the solution. Why? We got these H plus ions from sulfuric acid. So there were sulfate ions. So to both sides, because the sulfate ion does not undergo any change, it remains in the solution as it is. So you can add sulfate ions to either side. SO4, 2 minus ions to either side. Here also they are in the aqueous state. So then you can rewrite the full equation. So before that, if you look at this, this is a complete reaction, but here also we have charges. Now you all know a reaction has to be balanced. Zinc, 2H, H2, that is balanced, and the charges are also balanced. Here you can see 2 times H plus. So there are 2 positive charges, and on this side we have 2 plus charge. So the charges are also balanced. You can write the complete reaction where you write zinc solid plus H2SO4 aqueous, giving rise to zinc sulfate aqueous plus we will have H2 gas. So that is the complete reaction. Now so far we have only been dealing with this type of reaction. A metal reacts with acid to give rise to the salt and releasing hydrogen gas. You are familiar with that. But now you all have understood what really happens when you put a piece of zinc sheet into dilute sulfuric acid. So I introduced the terms oxidation, a species loses electrons, reduction, a species gains electrons, and when there are electrons and charges in a reaction, those are half reactions, or the equations are known as half ionic equations. So one particular reaction can be written as oxidation and reduction. That is how we get the electrochemical cell. So you need to understand these concepts first, students. Then only you will be able to understand the functioning of a cell properly. So we have combined the reactions. These are the half reactions. Zinc becoming zinc 2 plus, losing electrons. Hydrogen ions taking up electrons and becoming H2 gas. Those are half reactions, and the equations are half ionic equations. And when you add them together, the electrons get cancelled off and you get this equation. But since sulfate ions are there in the solution, you can write the complete reaction with all the ions there. So zinc solid reacting with sulfuric acid aqueous, giving rise to zinc sulfate aqueous and releasing hydrogen gas. So those are the observations. Zinc dissolves and hydrogen gas bubbles are evolved near the zinc sheet. Is that clear to you all, students? So then I'm going to move on to the next slide. Again, like I said, I will be repeating all these reactions. So this is what happens there, students. First we will look at what happens here. Here it can be observed that gas bubbles are liberated near the zinc and the zinc strip dissolves gradually. So gas bubbles are liberated near the zinc strip, and also zinc strips dissolve gradually. Let us find the reason for those observations. So before we go to that, you can remember, now we had the beaker, in that sulfuric acid, and there we had the zinc strip. This is zinc, this is H2SO4, and you were able to see gas bubbles, that is H2 gas, and also you were able to see the zinc strip dissolve. So zinc becomes zinc 2 plus aqueous. All those were the observations. You were able to see the zinc dissolving and going into the solution. Although you didn't see the zinc going, you were able to see the zinc metal dissolving, and you were able to see the hydrogen gas bubbles. So how did that happen? The first reaction, zinc atoms, that is Zn, go into the solution as zinc 2 plus ions, leaving electrons on the metal. So that is what we saw here, the first reaction. Zn solid, losing electrons, forming zinc 2 plus and going into the solution as zinc 2 plus aqueous after losing the electron. So this is how we write the equation. Zn solid giving rise to Zn2 plus aqueous, losing 2 electrons. So here you can see the electrons get accumulated on the zinc strip. That also I showed you. Now electrons get accumulated on the zinc strip. This process can be shown as follows using chemical symbols. So this is the process that I have already shown you. Zinc solid giving rise to zinc 2 plus aqueous, losing 2 electrons. Then we'll move to the next reaction. Sulfuric acid dissociates into hydrogen ions and sulfate ions in water. This can be illustrated as follows. So sulfuric acid dissociates. This is the second reaction. Sulfuric acid, H2SO4, aqueous, giving rise to H plus aqueous plus SO4 2 minus aqueous. I have already written the balanced equation. H2SO4 aqueous giving rise to 2H plus aqueous and SO4 2 minus aqueous. Sulfuric acid dissociates into hydrogen ions, H plus ions, and sulfate ions in water. You have to remember these terms. You are familiar with them, hydrogen ions and sulfate ions, SO4 2 minus. Then, what happens there? The H plus ions in the solution are attracted towards the zinc strip to capture the electrons on it. Electrons are negatively charged, H plus is positively charged, so they get attracted towards the zinc strip. That is also something you have to remember. H plus ions in the solution are attracted towards the zinc strip to capture the electrons on it. Hydrogen ions, after receiving the electrons, become hydrogen gas. Using chemical symbols, this can be written as follows. So this is how we can write that reaction. Two H plus ions, that is in the aqueous state, take up 2 electrons, giving rise to H2 gas. So this is also an important reaction. You have to remember this as well. So that is another one. We will move on to the next one. The reactions written as 1 and 2 above, depicting the conversion of one chemical species into another, either by removing or accepting electrons, are called half reactions. By adding two half reactions appropriately, the balanced ionic equation can be obtained. So again, to recall the half reactions, you can remember zinc solid becomes zinc 2 plus aqueous, losing 2 electrons, the first reaction. Then 2H plus aqueous taking up 2 electrons to become H2 gas. That is the second reaction. Students, I have written this already before also. I am rewriting here so that it's easy for us to add them and rewrite without going back to the previous slide. That is why I have written it again. So if you are asked to explain, you don't have to keep on writing it because you will have all your reactions written on one sheet of paper. It's easy for you all to look at the reactions, half reactions or half equations written above and write it below. The full balanced ionic equation. But for us, since we have it in the previous slides, I have written it again. Otherwise, you don't have to write it twice. So these are the reactions, first and second reactions. You can add them together. So once you add them together, you will get zinc solid plus 2H plus aqueous plus 2 electrons, giving rise to zinc 2 plus aqueous plus 2 electrons plus H2 gas. Now always we don't write any state for electrons, that I told you all before also. And from this, you know, you can cancel off the electrons. You have electrons on the reactant side and the product side. So they get cancelled out. So therefore, you can write this equation. Zinc solid plus 2H plus aqueous giving rise to zinc 2 plus aqueous and H2 gas. This is the balanced ionic equation. This is the balanced ionic equation. So now all the new terms. Here you can see the half reactions. Zinc solid becoming zinc 2 plus, losing electrons, and H plus ions taking up electrons becoming H2 gas. Those are half reactions. When you add them together to get 1 plus 2, you add them together, you will get this equation with electrons. But since you have the same number of electrons on either side, you can cancel them off and you will get this final equation, which is a balanced ionic equation. Here also there are ions. So it is a balanced ionic equation. With that, I'll move on to the next slide. Next, let us consider how this reaction can be represented by a balanced chemical equation. Now, we need to write a balanced chemical equation. Balanced chemical equation. The hydrogen ions H plus were added to this solution by the dissociation of sulfuric acid. When sulfuric acid dissociates, sulfate ions are also added to the medium in addition to H plus ions. But sulfate ions do not undergo any change. Sulfate ions do not undergo any change during the reaction. So we add sulfate to both sides. Is that clear to you all? We did that before also. So we got zinc solid plus 2H plus aqueous plus you add sulfate ions SO4 2 minus aqueous giving rise to zinc 2 plus aqueous plus H2 gas, and in addition to that you have SO4 2 minus aqueous. So you add SO4 2 minus aqueous to both sides because they are there in the medium. From that, what do you get? You get the next final equation, that is the balanced chemical equation, where you have zinc solid, H2SO4 aqueous. How do you get this H2SO4 aqueous? These two. 2H plus SO4 2 minus is H2SO4. Plus and minus. 2 plus 2 minus. That will be cancelled off. You will get the compound. So Zn solid plus H2SO4 aqueous giving rise to ZnSO4. Again, Zn and SO4 2 minus together, 2 plus 2 minus. So that becomes ZnSO4 aqueous and H2 gas. Is that clear to you all? So this is the balanced chemical equation. That is the balanced chemical equation. Balanced chemical equation. So we had the half ionic equations, then we had the balanced ionic equation, and now we have the balanced chemical equation. Is that clear, students? So here, students, we saw all the reaction. What happens to zinc when it dissolves? Then H plus takes up electrons, the half ionic equations. When you add them together, in the previous slide, we wrote the balanced ionic equation, and from there we get the balanced chemical equation. So that is what happens when you put a sheet of zinc or a strip of zinc into dilute sulfuric acid. So with that, I am going to move on to the next slide. Given above is the complete reaction for which zinc metal reacts with dilute sulfuric acid. So here, zinc metal reacts with dilute sulfuric acid. If the exchange of electrons taking place between the zinc metal and H plus ions during the above process occurs through an external conductor, we can produce an electric current. So like I told you all, what we saw, there was exchange of electrons. Zinc loses electrons, H plus takes up electrons. So if we can make the electrons to flow through an external conductor, then of course we will be able to produce electricity. So to do that, this is what we need to do. Now we had sulfuric acid there. We only had one metal initially. So we had dilute H2SO4, that is aqueous, and here we had zinc solid. Now if we put another metal into this, and if we can connect it by a conductor, you can make the electrons to flow through that conductor. Then of course we can generate electricity. That is when we get the electrochemical cell. So initially we only looked at this. Like I told you all, there should be two terminals. So we only had one terminal up to now. If we try to get two terminals, two electrodes, then you will get one electrochemical cell. So that is what I am going to discuss after this. So with this, students, I am going to end this chapter where we discussed what happens when we put a piece of zinc, a sheet of zinc into dilute sulfuric acid, and you became familiar with half reactions, balanced ionic reactions, and the balanced chemical reaction. So in the next chapter, we will see how we can have two electrodes together to produce electric current by making the exchange of electrons to occur through an external conductor. External conductor. So that is what we will try to do in the next chapter.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.